Hi, in this presentation, we will discuss the concepts of file permissions in Unix based operating systems. We will explore what they are, how to manage them, and why they are crucial for data security and system organization. By the end, you will understand how to control access to your files and folders, ensuring your system remains secure and well organized. Why we use file permissions? File permissions are essential for several reasons. They prevent unauthorized access to sensitive files like financial documents or personal information. Only authorized users can view or modify them. By restricting write permissions, you can safeguard your files from accidental modifications. This is crucial for your system files or shared documents. Permissions help organize your system by defining access levels for groups and projects. For example, you can restrict access to project files only for team members. File permissions in Unix. Imagine your computer has a house. File permissions act like locks on your doors and cabinets. They determine who can enter your files and folders and what they can do once inside. There are three key players. The first one is user, the person who created the file. Next, group. It is a collection of users who share access permissions. And the others, everyone else on the system who is not in the owner. So we treat it as others. Again, each category has three permissions. Read. It allows viewing the contents of a file or listing files in a folder. Write. It allows modifying the contents of a file or creating or deleting files in a folder or directory. The last one, execute. It allows running a file as a program or entering a directory. Numeric representations of permissions. We have seen that each permission type, read, write and execute, and has its own symbol. But there is another way to represent them using numbers. Here we see that a numeric value to each permission. Read permissions is assigned the value of 4. Write permission W gets value of 2 and execute permission X is represented by 1. For example, let us say a file has a read permissions for the user and group but no permissions for others. In numeric terms, this would translate is to 440. The first 4 digits represent read access for the user. The second 4 represents read access for the group and the final 0 indicates no permissions for others. Remember, these numbers are combined to create 3-digit code that reflects overall permissions for a file or folder or directory. How to view file permissions? To view file permissions of a file, simply open the terminal command, type ls-l followed by space and the file name. For example, ls-l file.txt. The ls-l command provides a detailed listing including permissions. Let us see how to interpret the output. The first character indicates the file type, example D for directory, hyphen for regular file. The next three sets of three characters, that is RWX, represent permissions for user, group and others. Within each set, R stands for read permission, W for write permission, and hyphen indicates no permissions. Next, understanding the common permissions codes. Familiarize yourself with common permissions code used in Linux. Here are the few examples. The first one is 755. Read, write and execute for owner. Read and execute for group. Read and execute for others, which is commonly used for executable files. Next, 644. Read and write for owner. Read for group and others, which is commonly used for shared documents. The last one, 700. Read, write and execute only for owner. It is used for private files. Let us see practical scenarios of file permissions in Unix operating system. The first one, to check the permissions of a file, ls-l. It gives the list of the files including directories. To check the file permissions in a directory, ls-lrt scripts. Scripts is a directory where sample.file.sh, directory underscore sample.txt, two files and one directory is included. If I would like to check the specific file permissions, then I can use the command called stat. Let me get into the scripts location where I can see two files, one directory. So I can give the state sample underscore file.sh. It gives a lot of information about the permissions, including the creation state. To check the permissions of a directory, ls-ldr, then give the directory name. Now let us see the modifying the file permissions. If you would like to grant read, write and execute permissions to the owner, then command called chmod. This is the command to modify the file permissions. So I would like to give the permissions to the owner, right? So users plus u plus rwx read, write, execution sample underscore file name dot sh ls-lrt sample underscore file name dot sh. So the user had the read, write, execution permission. To remove execute permissions from the group, same command, chmod g minus that all hyphen x sample underscore file name dot sh. Let us verify it has removed the permissions or not, execution permission or not. Yes, its group, it is removed. To set a read and write permissions for others, the same command chmod others, which permission we are going to set it, rw read write to file name sample underscore file name dot sh. To grant the read and execute permissions to all users, then chmod all users read and execute file name sample underscore file name dot sh. Let's query that sample underscore file name dot sh. It sets to all permissions. If you would like to change the permission recursively, that means, so in the directory what are the files and what are the files or directories are available. So to all the files and directories within the directory we want like to modify. That means I would like to give the permissions called 755 or 700 to the particular directory. Then I can use this command called chmod -r recursively. So which permission I am going to change it? 755. What directory we are going to give? Users Shekaram scripts directory underscore sample. Now what it will happen, it changes to the all the inside files to the 755 permission. The same way, if you would like to remove the write permissions for others, chmod -w write permission which we are going to remove, then file name sample underscore file name dot sh. Remove. Suppose if you would like to set the permissions for multiple files at a time. If you see this here, there are multiple files are there in my directory scripts. Let us get into the directory. Then I can see that there are two files, one directory. The two files are sample underscore file dot sh, one file, and second file is called sample dot txt. So I would like to give the permissions to all the files at a time. Then I can use the command called chmod. Let us give the 644 permissions sample underscore file dot sh, again sample dot txt. It can change all the files to the 644. Sample file underscore dot sh 644 permission. In the similar way, sample dot txt 644 permission. This is how we can give the permissions and revoke the permissions. And most of the cases we use permissions called chmod 700 sample underscore file dot sh, and again chmod 755 sample dot txt. And if everybody can wanted to access and execute, modify and all, then I can give the chmod 777 sample dot txt sample underscore file dot sh. This is how we can provide in real-time cases. The lastly we can say that D means directory, it is specified. Hyphen means it is a regular file. Thank you.